Yo, welcome back to another video. I want to put this one out as kind of an automation update, kind of what I do, some things I do. I'm not going to go super in depth. The reason for that is because some of this may turn into a talk, maybe, we'll see. But I want to do an update from some of the stuff I did before. I did a kind of like picture thing like this, and you can go back and see it. But since then, I've changed a little bit of stuff. I've made some stuff a little bit different. I kind of want to go over some things that have worked for me and not worked for me. Again, if you have questions after this, feel free to ask me. The other thing I will say, and the reason why I want to kind of make this video, is I know a lot of people actually in my Discord and other Discords that I'm in, that I interact with people in, a lot of people are starting to talk about automation more, down to like what VPS services they use or what hosting services they use, what their like services kind of look like not a whole bunch of like sharing code and stuff, but architectural decisions, scanning decisions, targeting stuff, like all that kind of stuff. So hopefully this kind of maybe starts a conversation with other people. Feel free to talk about stuff that you do a little different, or whether that's, out in public for the whole community to see, or whether it's with me. I'd love to hear about what some of you guys have built too, because I know you guys are building stuff too, so let me know. Anyway, so last time I talked about some different workers that I had, and databasing and Redis and all this kind of stuff. So some of that stayed the same, some of that changed. So some of the basics are here, and then we'll kind of talk about a little bit of architecture in the beginning. So one of the things that actually happens when you deploy in the cloud, if you deploy code in the cloud, you can deploy it as a Docker image, and that's kind of what I did, but I deploy a bunch of different Docker images based on one Go binary. So how that kind of looks, and why I say this is mixed and matched with one Go binary, is my code is all written in Go, and it's all one thing that can be like you just go build it into one binary. But at runtime, it takes in a configuration file that I can make, and that will actually determine what kind of a worker it actually is, whether that certain Docker image, so I have a Docker image where all of my workers are spun up. So if you needed just all of your workers, you can do that. But at the same time, the same Go binary with the config file, you can say, no, I just want more resolver workers. So when you're scaling something, if I only want to scale one of the workers, I can do that with the same binary. So what that lets me do is kind of without is a solo developer, without managing all these different repos and all these different deployments and stuff. It's all one big kind of modular monolith, I guess I would say. But you can deploy it using Docker and containers very differently. So if I want a resolver worker Docker image, it's the same Go binary, but in the config file that goes with it, it's saying, okay, we're only going to deploy 100 workers of the resolver type. And then it will do that. But that Go binary is written to do all of this stuff, and then it will manage whatever workers are running, and there's a little orchestrator piece that comes with this binary that will spin the workers up, whatever the configuration says to spin up, and then it will manage those too, so when it ends, it can close gracefully and monitor them and all that kind of stuff, which we'll talk about down here. The database is Postgres. I use Postgres. We'll talk about it a little bit when we talk about the architecture up top here, but I use Postgres. I manage everything from domains, DNS data, like IP, CNAMEs, all different kinds of records, web data, like web fingerprinting, endpoints, tech stacks, status codes, redirects, all that kind of stuff. And hopefully there will be a little bit more to that. That's kind of like one of my next projects, is kind of taking web fingerprinting to the next level. I tweeted about it a while ago, so stay tuned. Hopefully we can build something cool around that. I do some port scanning, just a little bit, but for a certain list of ports. Vuln data for any vulnerability scanning that I have, past and present, and then I can kind of work with that as I see fit, and then some other stuff too. Again, I keep that kind of low level, or a high level, I guess, because again, this may turn into a talk hopefully, so there will be more details there. Now, I talk about containerization. I still use Docker, and I do use Kubernetes. Specifically, the reason why I did that is because I've skilled up a little bit. I've done a little bit of experimenting with Kubernetes. And once you learn how to use it, it's actually super helpful. Everyone seems to be afraid of Kubernetes, and they just kind of stick to Docker, and they kind of run with scissors with Docker, and that's great. The thing with that is Kubernetes is really useful if you know how to use it correctly. There's also something that's starting to gain traction, I guess, or maybe it already has traction and I'm just catching up, called GitOps, which basically means you're managing all of your Kubernetes cluster state basically in a GitHub repo, or just a repo that's version controlled. And then that repository is the source of truth, and that's what it gets deployed from. So you can make changes to a GitHub repo to all the YAMLs and deploy it, and then automatically there's tools like Flux or Argo that will run on your cluster. and will pull your configuration automatically, and it will automatically update images, automatically update anything else, or add new things, or whatever it may be. And then you can look at the GitHub repository and you know your exact state of your cluster. So I kind of approach the deployment to my Kubernetes cluster with a GitOps approach. Again, if you Google GitOps, there's like more pictures and stuff like that. And I can do a video specifically on it, but it's like a pretty specific topic, but we can do it if you want. But so I use like a GitOps type deployment approach on Kubernetes. Now, in Kubernetes, there's two main ways of auto-scaling or scaling in general. There's pod auto-scaling. You're actually auto-scaling the pods that are deployed. And then there's node auto-scaling. And that's actually scaling the number of machines. Either it's VPSs or nodes, whatever, however it may be. So I deploy my stuff on DigitalOcean Kubernetes right now. So how I do auto-scaling is DigitalOcean comes out of the box with its own node autoscaler. So automatically, if you have something scheduled and the Kubernetes scheduler can't schedule a pod because of space, DigitalOcean, you can set a minimum and a maximum. And as long as you're not to your maximum, number of nodes that you want to pay for each month, it will automatically scale up your cluster so it can schedule that pod. And then once it hits a certain thing and it can move pods over, it will actually reschedule pods and move some stuff around, and it will actually scale down the pods as well as needed. So that is a mix of DigitalOcean and this other tool called Keta. At least that's how I say it. So Keta is actually an autoscaler that you can put onto Kubernetes. And the reason why I use Keta instead of Kubernetes built-in autoscaler is because Keta works with NATS. And I'll talk about that, but NATS is the queuing software I use on my Kubernetes cluster to queue up work and events and jobs and all that kind of stuff. So Keta can actually watch the specific NATS queue, like how many pieces of work or how many jobs are queued up. And if that gets to a certain point, it'll say, okay, I have to spin up another pod of this, Docker image that says, okay, we need more DNS resolvers or we need more web fingerprinters because the queue of web fingerprinting work is too much. Too much. So the number of workers that are deployed isn't enough. I'm going to schedule another pod, of that worker to be deployed. It will deploy. If there's no space for it to deploy, then DigitalOcean autoscaling will kick in and spin up another VPS and it gets put on there. So this is all the stuff about Kubernetes, is that like it takes work to set up, sure. But as a solo developer, actually like setting it up this way, once it works, it just kind of works and it scales and, scales up and down on its own. I don't have to watch it or deploy more Docker containers on my own or like use Swarm commands or use Docker commands or whatever. You can use things like ECS for this on AWS or like some of the other stuff that will also just auto scale Docker containers for you. That works, but again, you don't get stuff like Keta with it that will actually specifically watch the NATS queue. You're just kind of running off CPU, and like that works, but it kind of doesn't work. And really, I want to scale off of jobs. Like if my queue is getting stacked up with work and the workers can't consume it at the rate at which it's, incoming, then I need more workers. And that's when I want to auto scale. That's what's actually important to me. So this whole setup works for me. I'm not saying you have to use Kubernetes or anything like that. This has like been a work in progress for a long time. And then again, I use cloud native monitoring. There's libraries for every language to export metrics of any kind to Prometheus and Loki, which is basically the log version of Prometheus. And then you can view it with Grafana and everything's great. And it just works out of the box, especially on Kubernetes. And you can just shoot whatever metrics you want up to it and you can put it on little graphs. And almost every software that I'm using that I didn't build. So for instance, like I talked about NATS, like NATS has like Prometheus metrics exported out of the box. You just hook it in and go. The resolver I'm using, not resolver, which we'll talk about later, has Prometheus metrics out of the box. You can just hook it up and go. So I can see how my resolver is running. I can see how my queues are working. I can see how my applications are running, error count, domain resolving count, how many domains I'm resolving per second, like da-da-da-da. All that stuff. Cloud native monitoring, again, it just all kind of comes bundled into Kubernetes. It's kind of a pain to set up. There's a lot of docs, read a lot of docs, tweaking a lot of configuration. I get it. It's kind of like a time sink. But once you get over the plateau of like setting everything up and you get on smooth ground, like really then your rate of just focusing on only this part and only my application is amazing. Because now everything else just scales for me, deploys for me. It's all CI/CD hooked up, GitOps for deployment. like everything just works. The monitoring's there. Like it's great. The other thing too, again, this skills, I put skills down here in the database because ideally I've upgraded my skills a little bit. I've read a lot of data engineering stuff, and I'm trying to do like at least some like joins and all this kind of stuff, and like using the database correctly to try and like hold some kind of like state and all that kind of stuff. So the reason why I bring this up is because if you're building automation, use a database. Like please, 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 please don't use a text file. Postgres is open source. Like SQLite is open source. Like just use a database and do a little bit of research on like how to use SQL and how to implement it and like how to do some joins and how to, relate data to each other and query it and store it and all this kind of stuff. It's so worth it. I'm promising you, if you're doing high, like you really want to scale automation, it's so worth it. I am still such a database and like DB noob, but just the bare basics is so like upskilled from a text file. I'm telling you. Okay, so I think I have most of this covered. Again, the Go binary thing, I can answer more questions about if that's a little fuzzy. I can answer more questions about any of this. I just kind of want to give an overview to kind of start a conversation about what I'm doing and like what other people can do. Again, so this really scales to big, right? Like as many as you want, as many as you're willing to pay for, DigitalOcean will scale you up, right? So this makes it very easy for me to both scale up and scale down. So if for some reason I do have downtime and just everything has been scanned and that's all great, then it'll scale back down, right? Keta is going to be watching my queues, and if my queues go to 0, it's going to scale me all the way back down to nothing, right? So that's good. Now, a little more like architecture-y stuff. I think I covered everything on here. Again, these are there's more, I think a few more that I'm missing, or like subdomain enumeration is like one box, but it's like really a ton of things. I do like certificate stuff and some passive API stuff and like actively monitoring certificates and some other stuff like that. So that's kind of a thing. I mean, when I say DB worker, what I really mean is like querying against the database to try and get old data and renew it, or check data against itself and see, alert on stuff and like what may be important for me to know or to retest or whatever, to put back in queues, all that kind of stuff. Again, there's some more here, and your services can be whatever they may be, and you can have multiple binaries and all that kind of stuff. I like to use one binary and then a config file, and then this binary with whatever configuration I want can make a ton of different Docker images. And then those Docker images I can save and then pull later into my Kubernetes cluster as all different kinds of containers. So for instance, I'll have one Docker image that's like the all workers Docker image, and then I'll have one that's like just resolvers, like a resolver upgrade, right? So when I need to deploy, when Keta decides like, hey, I need to auto scale your resolver worker, it will pull the resolver image, and like that's it. Same thing if it's web fingerprinting or any of the other services, right? Okay, let's see. So this is kind of, again, like I didn't like make it like a big cluster, but there's like infinite number of nodes like stacked up here, right? Because it's on a Kubernetes cluster. There can be one, there can be 1,000. Like it's really, again, however you want to pay for it. But each node, I have the cluster set up. So each node, whenever a new node gets deployed onto the cluster, every node will obviously have some kind of service on it. When services, by services, I mean some version of this Go binary and some kind of an image. But every node that gets deployed automatically also comes with Not Resolver on it, like a local version of Not Resolver on it, just out of the box. The reason for that is because both of my DNS workers and web workers and stuff all use the local Not Resolver for literally, I think it was my last video. If you watch my last video on like how I do DNS resolution, this will all make sense. But that way, whenever a new node comes up, it always has the Not Resolver local, so that all of my services can just hit localhost to do the DNS recursive resolution for them with a Not Resolver. Now, again, I'll just buzz over this quick. If you have questions, let me know. But all my services, I actually use Memcache for caching. The reason why I do that is because Memcache, out of the box with no configuration, no having to like mess with it, has expiration on sets. So I can set something, I can set a key value pair with an expiration and it'll expire. Why do I do that? So that when stuff is getting ingested from my NATS queue, the caching is how I check if I've seen this in a certain window of time, right? So if I want to make sure, let's say for my DNS resolving service, that I'm only resolving a certain domain, or I'm only attempting to resolve a certain domain once a minute, right? But for some reason, like The subdomain enumeration services, again, because there's like really a few different sources. There's a ton of different sources that kind of all feed in, and then they all need to be resolved. Like, let's say for some reason the same domain gets pushed in 15 times, right? And it's like boom, 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 the same domain 15 times. Using Memcache, the first time I see that domain, this will push something to Memcache that says like, okay, I tried to resolve this domain, this like, and then set this key, like DNS resolving : the domain, and set that key for a 5-minute expiration. And then every time I get something, because it's cached, it's super fast. So the DNS resolver service just has an extra step where every time the first thing it does when it ingests from NATS is checks it against the cache. If there's a cache hit, that means I've done it already in the past minute, and I can just drop it. The work's already been done, I can just drop it. That's right now, that's how I'm checking for like duplicate work. So some of the services that I don't want to continually port scan the same thing over and over again on accident, or continually hit something with, on the web over and over again, right? So all that, I use caching that tells me like, if I've hit it within a certain time window. And again, let's say it's a minute. So I do DNS resolving on something, because it wasn't in the cache, and I save it to the cache, right? Now I set it with a 1-minute expiration. So after a minute, there's no code to like go delete that after a minute. It will just expire after a minute. And then if the DNS resolution comes back and checks it again, it's gone. So it'll now set it and do the resolution, right? NATS I've talked about many, many times. I've used NATS for a while, just as queuing. I use NATS Jetstream. I use it as, for queuing all my work and all that kind of stuff. And then Postgres we already talked about. Right, so this can scale up and down. I have it set where every time a new node comes up, a local NOT resolver comes with it, so that any services that need access to DNS, which is quite a few of them, can hit it, and you're off to the races. So this kind of stuff does most of it. Again, for alerting, I guess I didn't really put it on here for alerting. I just use Discord webhooks. I mean, you keep it simple. This is like a really high overview of a lot of it. There's more stuff that kind of goes into it and whatnot. I'm kind of purposely saving that, but I hope some of this gives a little bit of information about how, if you are interested in like building a system, again, I'm not giving you any of the code, but a lot of this code is not hard, especially nowadays with vibe coding or like whatever you want to call it. It's really not that hard to get something started, get something scaled. I promise you, Kubernetes isn't that hard. If you're already deploying something as a Docker container, you're like, I don't know, 50, 70% of the way there. I mean, whatever you want to say, depending on how intense you want to get. I will tell you, if you want to start with Kubernetes and just play with it low key, I have some videos on like downloading K3s locally, and you can do it with Ansible and one command and all this kind of stuff. And there's cool resources out there to test Kubernetes locally and just play with it for free. Literally put it on an old laptop, 1-node Kubernetes or a couple node Kubernetes if you have a couple laptops or something. Super easy to play with. The other thing you can do that's actually really interesting now is you can do something like Minikube for sure, but Docker Desktop and OrbStack on Mac, which is insane. You should definitely look at OrbStack if you're a Mac OS user. Have a Kubernetes cluster, a 1-node Kubernetes cluster that you can just turn on, and then you just have one on the device that you can deploy to and use and whatever. OrbStacks is really good. I've used Docker Desktops like a few times, but the OrbStack one is a little bit better in my opinion, but it's super fun to use, super easy. You just click the thing, turn it on, and you can start testing on Kubernetes. And, again, read some docs and try it out. But this is what I do. I'd love to hear what you guys do. If any of this is confusing or you would like to see a separate video on just one particular piece of this that you think should be its own video, let me know. I'm definitely open to suggestions or ideas. But otherwise, this is a little bit of an automation update and kind of what I do at a really high level. And, let me know what you think. But that's all I got for this one. Peace.